Just wait till others join in. Can you guys hear me?
Yes, sir.
Okay. For this classroom, I'm not sure whether, because skill classes will be in the morning half. So we can have it online, but the problem is that we have to say prepone at least by 15 20 minutes. We can start at 10 or 10:15, because again, here along with the IT MTech students. So but that will be physical. So because 10:30, whenever we are starting, by the time I start, it becomes 10:45. So that is a problem. So what I'll try to do is that I'll try to prepone it by 10:10 or 10:15. Is that okay?
Okay,
Yes,
sir.
Okay, so we'll not be having all of you are having all the 5 days vacant, but I may not be taking all the 5 days. I may be taking say 3 or 4 days weekly, but I'll let you know beforehand because we have some prior commitments. And by the way, our department will be conducting a Atal AICT workshop on quantum computing under this Jayantapal sir. So some of you know about it, or our department students, I think you know about it. From 8th, you are having a quantum computing workshop. Have you received the mail from Jayanta sir? Okay. So others, if you want to join in, at least the electronics students, you may join in because it is quantum computing and it is more related to you guys. And for electrical students, if you are working on energy domain and if you feel like that you can apply some quantum computing ideas in your energy domain, you can think of it because basically those who don't have much idea of quantum computing just take into account that it is something like your digital only. Only difference is that we are using the spins of the electrons instead of the digital boolean 0 and 1. We are having 1 along with 0 and 1. We have a undefined state which sometimes becomes 0 and sometimes becomes 1. So that is the quantum computing, and 0 and 1 is based on classical computing. So statistics students, it may not be much relevant to you, but for others, if you want to work on that area, you can join because we'll be having 2 workshops. The first one is the preliminary where we will be learning quantum gates because all of you know digital gates. So from digital gates, we'll be proceeding to quantum gates, and this is the basic workshop. And next year, January or February, I forgot, we'll be having the advanced workshop on this. So 5 days this month, sorry, November, and again 5 days in January or February. And all the experts of different universities and NITs and IITs will be there. So if anyone is interested, you can join, but joining link has to be done via the Atal this website. So you have to join in, and still I think up to this week there is time if anybody has not yet joined, or you can contact Join the Pulsar if anybody is interested. Okay. So with that, coming to we were discussing reasoning under uncertainty. I'll be sharing my slide. You just see uh, if you can see my screen. You can see my screen.
Yes, sir.
Yes, sir.
Okay, so I had covered up to this part, I guess. Base classification, did I cover? The bird flyer young thing, I think we had done the probability calculations. Okay, Smita, I'll put it there. Or if you are coming for offline classes, he is in first floor only. I'll be sending you the contact details.
Okay, sir.
And did I take up the Bayes rule and other things? Stiff neck, meningitis. Did I discuss that?
I think no, sir.
Okay. Up to this, I think I had discussed.
Yes, sir.
Okay. Conditional probability. Conditional probability, posterior probability, Bayes rule, these parts.
Yes, sir, it's done.
Okay, I think up to this bird flyer young, the Bayes rule was left, I guess. I'll start with the Bayes rule. So using Bayes rule, you have the probabilistic reasoning here. So what we have is that I'll be discussing an example, maybe the final example I'll be discussing in tomorrow's class. So today you can just have a look in the Bayes and how we are applying that. And tomorrow I'll be discussing an example on this. So here we have to take new pieces of evidences and we have to apply, and we'll be increasing the probability based on whether the evidence is positive or the evidence is negative. So why do we use this? Because and this is very important, because later on, when if anybody has earlier done the neural network course, there you will be saying that Bayes classifiers are used for neural network also, and probability distribution and Bayes is actually very hand in hand. So when we want to know the probability of A conditional B, but we have only the access for B conditional A, for this kind of cases, what we do is we apply, say, for example, for the stiff neck, if S is equal to stiff neck and M is proposition that the patient has meningitis, and we can correlate stiff neck and meningitis, then this doctor, what he would like to know is that what is the condition of meningitis for stiff neck, or if he has the idea that what is the condition of stiff neck for meningitis, means one is PMS, another is PSM. So here based on the different say seasonal factors, because you can have stiff neck in various ways, but for meningitis you have stiff neck. So if we correlate these two together, so whether it is PMS and PSM, one is meningitis for conditional stiff neck, and stiff neck conditional meningitis. There are two different things. Means somebody having stiff neck may have meningitis, and somebody having meningitis may have stiff neck. But one is guaranteed, whereas the other is not guaranteed. So if you accumulate the statistics that is defined for those meningitis, those candidates having meningitis with stiff neck, and those who had stiff neck and later on tests they found that they are having meningitis. So if you correlate that, say if you see the different propositions, you'll see that here, like for example, if you see that PM is 1 out of 50,000, that is probability of meningitis is 1 out of 50,000, whereas PS means stiff neck you can have any time. Say somebody is sleeping in any way, or say roughly this way or that way, if you're sleeping, then you are having stiff neck. So stiff neck may be due to anything. So stiff neck is very common, whereas meningitis is a bit more uncommon compared to stiff neck. So if we take the probability of PSM, so that is stiff neck having meningitis. So if you have meningitis, normally you have stiff neck. So that is very high probability. Whereas what is the chances that you have stiff neck and it may be meningitis is actually half of that. Okay. So here this is of high probability, means if you are having meningitis, it is very probable that you have a stiff neck. But if we see the Bayes rule, and we can find out the other way around, means if you have stiff neck, what is the probability that you may have meningitis? So that is 0.002. So normally the probability of meningitis is this, and in case you are having stiff neck, that time your probability of meningitis is 0.0002. So it is much higher than this one, isn't it? So here it is 0002, and here it is 0.0002. Okay, clear up to this? Anybody having any questions? I'll be discussing this again. You can just correlate it with COVID positive and runny nose. Somebody पहले क्या होता था, कोई छींकने से बोलता ब्लेस यू बोलता था, अभी बोलता छींकने से बोलता है कि कोविड है कि नहीं. So we know that, say let me just correlate for in general. So there is chances that you may have COVID 1 by 50,000, and instead of stiff neck I say that you have cough and cold or runny nose. And here when you are having COVID, there is high probability that you will be having a runny nose. So if I apply Bayes rule, then nowadays that is why people are saying that if you are sneezing, there is chances that you may have COVID, because here it is the correlation of these two. Okay, so here we are applying the Bayes formula. And what is the Bayes formula? You have 1 by 50,000 and you have 1 by 20. So 1 by 20 PS divided by PM and PM and PS divided by PSM. So you have this 1 by 5,000. Okay, clear?
Yes, sir.
Okay, so combining, if you have different evidences, because like earlier it was evidence that normally meningitis people have a probability of means every 2% having meningitis, if you cross check you will see 1% is having a stiff neck, so that is common. Like every COVID person, if you cross check, so there may be more number of people having a runny nose. So that option is there, so you can apply Bayes in that way. Now here we are going based on the evidence. Evidence is the number of probabilities where we are having these more people having this kind of symptoms and other things. And as I am working on healthcare, I'll be giving more examples of medical domain using the probability. Okay, so don't correlate with it, because it is because medical is a field where we are applying too much of probability and AI, like your MD medicine or any other medicine people are applying, and it is a non-linear system. So please don't get bored. Most of the examples that I'll be taking up today and you have seen earlier also, that I'll be all applying different medical domain ideas, because I work on that domain. So generalizing, if you generalize two pieces of evidence B and C, what you have, probability of A for B and C is equal to probability of A, probability of B and C for A divided by probability of B and C. So if I take this into account, what we can do is that here this can be correlated as, we can take this probability of A out, and we have this probability of B, C and A, which can be converted into these parts. So this shows how this conditional probability of A is updated with respect to B and C. And somebody has joined in, I guess. Okay, so then if you see the probability for this problem, it is hard to compute this particular C conditional A for B. So for that, what you have to do, because here it is the other way around. We have evidences B and C for A. So we are correlating A conditional B for C. And here we are seeing C conditional A for B. So it is very hard in general to compute. But what we can do, if I say that A is unconditionally independent of B, that is A conditional B is equal to PA, means it is independent of B. When we have PAB equal to A, means A is not at all dependent on B. So in that case, PAB is equal to PA into PB. So again, if it is independent of both B and C, then B, and if we have a C, then P conditional A conditional B is same as PA. So PA is here, and only C, because B is not, because conditionally independent of B, so this B is taken out. And based on that previous relation, symmetrically, if you see here, it is PB conditional A CP. But unless we know that one of them is independent, we cannot apply this. So what we can do is that separately we can consider one at a time. Say I'll consider A is independent of B and then find out the solution. Then I'll consider A is independent of C and find out the solution, and then we can correlate. So based on this, we don't need to keep this. If we know PAC, then we also know PBAC, because this A is conditionally independent of B. So based on this relation, we are having PAB conditional C can be written this. But here you have to think that we have considered A being unconditionally independent of B. So unless we have that, we cannot uh, find out. So if we can strategically do it once making independent of B and once making independent of C, we can find out the each other relation. But otherwise, it is very hard to obtain. So if there are multiple things and independent evidences, we have say two pieces like B and C, then here you see PA, BC, PA, the same thing. Okay. Only thing is that here we have the C conditional also. Okay. So based on that we can have this. So PA, PBA, PCA. Okay. So this is used as a naive base classifier because it is called naive because it is not aware of one particular idea. So if we have a random variable C, it represents the different possible ways where we can measure it. So here C is a set of, we can have possible classifications which diagnoses the different your medical domain diagnosis kind of thing. So this is that's why I said that I want to give you an example for that. So if I take an example like if there are different values possible for C, say A, B, and C, uh, we have measured say E1, E2, and En. So what we can do for P, C equal to A, C equal to B, and C equal to C, for we are finding the different evidences E1, E2 up to En. For B also E1, E2, En, and for C also E1, E2, En. So like this, if we take all of them, then this C denominators are same as above, so they can be ignored. So if I see it do for C A equal to A, for that we have this, and we have to choose the value of C that gives highest probability, and when we if we have to find the relative ones, and when it is very small, we can take the log versions of this probability, and B and C, if they are unconditionally independent, then we can have it in this way. But if they are conditionally independent, it will be different. So going for the example, say we are taking three things. One is this is called liver cirrhosis. Most of you other than the statistics guys and MCA guys are engineers, so you know that many of your friends are into, say, due to heavy drinking and other things, means those who are one or two cases are there who don't study and engage in this kind of affairs, they are having problems of liver cirrhosis. That is a very common problem. It doesn't always happen only for drinking. You can have a alcoholic or a non-alcoholic fatty liver also, जो cheese butter ज़्यादा खाता है लेकिन his liver is not habituated to it. But chances of probability of alcohol based liver cirrhosis is very common. So I'm just taking one example from that. So we are taking three things. So this liver cirrhosis is in general called pickled liver. Pickled liver मतलब liver pickle जैसा सड़ गया है liver. Okay, and this is called this is a symptom of what? Yellow eyes. Can anybody tell me if you have this eyes yellow? It is very common. Many of you might have had it.
Jaundice.
Jaundice, sir.
Yes. The first one is liver cirrhosis. Second one is jaundice, and the last one where the eyes are red. What is that? Eyes are red, means blood is there in the eyes. Anybody? It is called bloodshot or bloodshot eyes. It can be due to conjunctivitis also, but in conjunctivitis it is different thing. But when you have liver cirrhosis, you have both of them. Okay, means here this is red and this is yellow. But when you have liver cirrhosis, you have both of them. Getting the problem? These two are independent of each other. But if you have both of them together, then the chances of you having liver cirrhosis is very high. Getting? So, the first one, instead of liver cirrhosis, I'm calling it pickle liver, jaundice, bloodshot. Okay. So the first one indicates a given person has a pickle liver. The second and third are symptoms of the patient. These are two symptoms because I cannot directly open and see his liver. After the liver function test as well as taking the ultrasound and USG, only we can know that he might have liver cirrhosis, okay, or a pickle liver. So second and third, these two are the symptoms of the patient. Clear up to this? So we assume that these two are independent. Jaundice can happen to anybody, bloodshot can happen to anybody. Clear up to this? So these are my B and C. Okay. Jaundice and bloodshot are my B and C, which are independent of each other. And separately we have A, which is my main target, that is the pickle liver or liver cirrhosis. And I am a doctor and I want to find out whether the patient is having liver cirrhosis or not. Okay, based on the symptoms. And initially, as I want to find the likelihood that the patient is having a liver cirrhosis, what I do is that I know that the probability of one person having pickle liver or liver cirrhosis is 10 to the power minus 17. Means it is 1 by 10 to the power 17 or 10 to the power minus 17, whatever you consider. So that is the probability. So this is my initial belief that अरे ये आया है, इसको कैसे liver cirrhosis हो सकता है, ये तो बहुत अच्छा लड़का है, ये बहुत अच्छा लड़की है, इसको liver cirrhosis कैसे हो सकता है, और ऊपर से वो बोल रहा है कि he or she is not drinking. So there is very less chance of he or she having liver cirrhosis. Okay. So that is the initial belief or initial probability, you can say. Going ahead, on examining, say we find that this person is having jaundice. So any person having jaundice is probability is 2 to the power 10. Okay, so that is very common. Anybody can have jaundice. Even newborn babies are having jaundice. Okay, clear up to this? But the conditional probability that somebody with pickle liver is having jaundice is with jaundice is having pickle liver is 2 to the power minus 3. So pickle liver means you are bound to have jaundice. It is very highly probable, unless you are having non-alcoholic fatty liver or non-alcoholic jaundice kind of thing. Unless you have that, you are bound to have this. I'm considering that this is due to alcohol only. If I consider due to alcohol, this is the probability. And if I consider without alcohol, it may be different thing. So jaundice conditional with pickle liver is 2 to the power 3. So it is having much higher probability. And now if I find that the patient is having jaundice, so my probability, which was earlier 10 to the power 17, will increase. How? 2 to the power 17 multiplied by, oh sorry, I made it 10 to the, it will be 2 to the power 17. Okay, just this I put 10 here. So 2 to the power 17 and 2 to the power 3 and 2 to the power 10. Okay, 2 to the power 17 is in general belief, that is probability of pickle liver. Then here probability of jaundice and pickle liver is 2 to the power minus 3, and probability of jaundice is 2 to the power 10, means anybody can have jaundice kind of thing. So the conditional probability of pickle liver with respect to jaundice is 2 to the power minus 10. Okay, so the probability has increased from 10 to the 2 to the power minus 17, it has increased to 2 to the power minus 10. Clear how it has increased? डॉक्टर ने देखा कि उसका आंख येलो है और जॉन्डिस का पूरा सिम्टम्स है, तो बोला अरे जॉन्डिस का सिम्टम्स है तो इसको तो लिवर सिरोसिस भी हो सकता है. तो इनिशियली द प्रोबेबिलिटी ऑफ लिवर सिरोसिस वाज 2 to the power minus 17. Now it has increased to 2 to the power minus 10. So as we go ahead, this increases the belief of the doctor from 2 to the power 17 to 2 to the power 10. This is the first stage. Now I bring in the, till now I have not discussed the bloodshot part. Now let us bring in bloodshot. So we see the eyes properly and we see that there are bloodshot also. A yellow के साथ उसका background yellow है, साथ में bloodshot भी है. तो now I know that अरे इसका तो bloodshot है, तो it may be more severe than this. So we take the probability. But bloodshot का probability है 2 to the power 6. वो तो होता है कभी भी. जैसे 2 to the power 10 is for jaundice, 2 to the power 6 minus 6 is for bloodshot. वो conjunctivitis के लिए भी आँख ये हो सकता है. कोई रात को नहीं सोएगा भी तो उसका हो सकता है. So now if I correlate with this, bloodshot and pickle liver is 2 to the power 1 minus 1. So pickle liver होने से bloodshot होना मतलब 50% probability है. So it is 2 to the power minus 1. Now what I do? Now I compute the new conditional probability. Pickle liver with jaundice and bloodshot together is 2 to the power 10. This is the pickle liver and jaundice. And then we have 2 to the power minus 1 and 2 to the power minus 6 for the bloodshot and for bloodshot and pickle liver together. So now the new probability is 2 to the power minus 5. Abhi और probability increase हो गया. So taking into both the symptoms into account, the doctor's belief is the patient has pickle liver is now becoming 2 to the power minus 5. तो क्या हुआ है, ये आँख पहले जॉन्डिस वाला था, फिर इसमें ब्लडशॉट भी हुआ, तो देखा कि ये तो ऑरेंज हो गया, येलो और रेड मिलके ऑरेंज जैसा हो गया. So pickle liver. Okay, so this is a prediction of pickle liver or liver cirrhosis. अभी prediction तो prediction है, तो finally we have to go for the test. ये तो डॉक्टर देख के बोला है. इसके बाद जब टेस्ट करेंगे, अल्ट्रासाउंड करेंगे, उसका ब्लड टेस्ट करेंगे, लिवर फंक्शन टेस्ट करेंगे, जॉन्डिस है या सिरोसिस है या जो भी है, it will finally come out. Getting how I am correlating probability A, B and C for using the base classifier?
Yes, sir.
Yes.
Clear this part?
Yes, sir.
Okay. Now I'm coming to the Bayesian networks, which are also called the belief networks. If anybody is working in any field, अभी statistics वाले भी belief networks या Bayesian networks use करते हैं deep learning AI के साथ, electronics वाले भी use करते हैं, IT, computer, then electrical. Anybody can use these belief networks, whether for any type of prediction. So for these Bayes net, belief net, causal net, probability net, whatever you call, they are all based on full joint probability distribution. And in लोग का main base is based on the statistics and probability. So here the statistics and the probability guys play their main part, whereas the other engineering background or computer background people, they use the help of this mathematics into and apply that into some application field. So that is the applied field. So they use the statistics and do it for some application. And so for this Bayesian net, you can compute any value with full joint probability for a different set of random variables. And you can represent the direct and causal relationships between the variables accordingly. So intuitively, what you can do is that you can construct the Bayesian net for any given set of variables, draw arcs, and this is called direct acyclic DAG. Okay, so many real world problems are solved based on that. And those who have done say data structures, you might have heard about data flow diagrams, DFDs. Anybody has heard of DFDs other than the MCA and IT guys? Electronics, electrical statistics, have you heard about DFDs? Data flow diagram. IT and CS and computer application, they have done. Others? Any idea? DFD?
Yes.
Okay. So these data flow diagrams that are there, so many real world problems, what we do is that, and anybody who is into say those who have used MATLAB, I think statistics guys might have not used, but electrical and electronics guys have used. There is something called sim events. So you can nowadays in MATLAB you can do block diagram of Simulink based events, whether it is a digital operation, whether it is a any other operation. So this that's why what we can do here is that we can say correlate them and we can get those into account. So what we have here is that you have the different dependency variables which you can correlate for different problem domains, and you can draw the data flow diagram and in between how the decision making is done. So as I continue, you can capture the qualitative and quantitative relations between the variables, and they can be used for reasoning. Either you can do forward. It is called predictive reasoning. Means you are predicting something. That is, or it is called causal reasoning. Causal means those who have studied digital signal processing, you know, causal is when we are having the inputs with us. Okay, causal means you are not having any past idea, but sorry, you have some past idea and you have the inputs with you and you do some prediction, means what will be the output. So that is predictive reasoning. So it is called a forward or top down, and similarly we have the reverse one which is called the backward or bottom up. So there it is diagnostic reasoning, like the one that I discussed earlier. So diagnostic means from your symptoms I want to find out what has happened, whereas the first one is this has happened, so due to this, because you are drinking too much alcohol, due to that you can have liver cirrhosis. So that is forward effect, and it means I am predicting, अरे ये तो ज्यादा पी रहा है तो इसका तो liver cirrhosis होगा. And backward is इसका liver cirrhosis हुआ है तो पक्का है कि ये पीता है. Getting clear? So one is diagnostic reasoning, one is the predictive reasoning. So two types of reasonings are there. So here we use the Bayesian net, or it is called directed acyclic graph, DAG. And here we can see how we can have these arcs correlated step by step, like your data flow diagrams. You can have the flow diagrams between that. Statistics guys, you don't get confused. You are the ones who are the statistics guys are there, I guess. स्टैटिस्टिक्स वाले हैं कोई कोई क्लास में?
हाँ
आज तो
सर।
कम लोग हैं, 20 लोग हैं. So you are the one who are taking into account these things. So probability जो है उसको हम लोग क्या करेंगे, with block diagram we are correlating from this side to that side. उसमें हम लोग probability का values डालेंगे. Okay, so you are the one who are giving the base of this. So when I'll be discussing one example, the example I'll not be discussing today. The example I'll be discussing say the tomorrow's class. So we will just represent the probabilities with diagrams. Along with the diagrams, in the arrow I'll be putting the probabilities. Means it is when you see any mathematics class, oh ज्यादा probability P equal to this, P O equal to this, P A B equal to this, इतना सारा confusing है. इसके बदले हम लोग जो engineers है, we are से ज्यादा mathematics हम लोग मैथमेटिक्स यूज करते हैं, लेकिन ज्यादा मैथमेटिक्स होने से भी हम लोग को डर लग जाता है. सो व्हाट वी डू इज दैट डायग्राम बना के उसमें प्रोबेबिलिटी का वैल्यूज डालेंगे, ताकि मतलब वो डाटा फ्लो भी पता चले एंड वी कैन पुट द probability also into account. So I'll be discussing that in tomorrow's class. Anyway, so what we'll do here is that the arcs, or you can say data flow acyclic graphs that are there. So we have some occurrences like A supports B and vice versa if we are having. So it may be backward like diagnostic or evidence based something we can do. And here we'll have different nodes and the nodes will be connected to one another. So we can have some net topology or conditional independence assumptions, like if you have P, B, A and C, like we were discussing the liver cirrhosis, then the bloodshot and jaundice. So we are having A, B and C kind of relationship. B and C are independent of each other and A is there. So we'll draw it like this. Okay, clear the diagram? कुछ ज्यादा झमेला वाला नहीं है, simple है, isn't it? Clear? So the same thing we can do. For example, if I use the cavity, So if we take care into the cavity and toothache and dental probe catch and other things, what we can do is we can have two events which are conditionally independent of each other, and say I have toothache. So if agar mera दांत में दर्द है, it may be that there is toothache is because there is some cavity in my tooth, ज्यादा chocolate खा लिया इसलिए toothache हुआ है. It may be the other way around के कहीं पे दांत में चोट लगा, so then also it may be I may be having toothache. So if we know that is that someone has cavity or somewhere there is some catch proof क्या होता है? So when जो लोग dentist के पास गया है, you will see that nowadays you are having a catch proof kind of thing which they put inside, and उसमें drill करके cavity को साफ करते हैं, और उसके बाद उसमें क्या करते हैं, वो स्प्रे टाइप का कुछ करते हैं. ओके, डेंटिस्ट के पास कोई कोई गया है, फिलिंग विलिंग कराया है छोटा में या बड़ा में? यू हैव गॉन टू द डेंटिस्ट? So there, have you seen there are two equipments that they use? One, they blow cold air, and it if you have a nerve coming out, you feel that spiky thing, isn't it? And one is the drilling, which they do to remove the cavities. You have seen these two things?
Yes, sir.
So here the toothache may be due to catch probe also. It is called a catch probe, and the cavity, one is toothache, one is probe catches. So probe catches and toothache, they are independent of each other, but they are both related to cavity. So it is similar to the jaundice and bloodshot with respect to your liver cirrhosis. Okay. So if you go for example, in general, what we do, we called the parents and we can call the nodes. एक ऊपर वाला parent वाला होगा और नीचे वाला ये kids type का होगा. And this we can apply in genetic algorithms also. I'm not going to genetic algorithm here. So the probability distribution here x1, x2, x3 करके बहुत सारा होगा. So if we put xi, so xi का parents, I means x1 का parents, x2 का parents, x3 का parents, and we'll have the conditional probabilities with all of them, and hence we may not need a full joint probability distribution here because some of the things are not correlated with each other. Okay, so I'll be discussing one of the examples tomorrow. I'll be taking a problem domain and I'll be discussing that. So up to this, and electrical also, those who are interested. Because this quantum computing, the basic workshop anybody can do. Why? Even the statistics guys can do, because everybody knows digital, and from digital how they are going to quantum, that is the main idea. The advanced one, if you don't attend also, is not an issue, because the advanced one which will be next year, say January, February, for that one will not be discussing basics. It will be totally application oriented, and the next generation computers that are coming to the market are quantum computer based. Okay, so for you, at least even if you don't attend the second program, even for the statistics guys, I will say that it is good if you know about the basic quantum computing. अगला next generation में हम लोग ये normal computers use नहीं करेंगे. We'll be using quantum computers. So as this is a very elementary workshop, means they'll be discussing from the basics, so it is very easy for everyone. Even if the statistics people are not very much aware. Even somebody from physics or chemistry can attend, because chemistry guys, they use quantum chemistry, physics use quantum physics. So you have quantum in everywhere. Only thing is the application is different. Okay. So those who are interested, you can just join in, or if you can go to the Atal website, AICT Training and Learning, that is called Atal. Okay, I'll do one thing. I'll share the details in your this. Yeah, Vishal has shared the number. I'll share the this in the Google Classroom. I have to share the previous slides also. I have forgotten to share. So I'll be sharing that, and I'll be sharing the link of Atal FDP. If you are interested, you can join in. Uh, Normally, for because you all are in-house or having the affiliation of Tripura University, in-house we are allowed 30% of the candidates, but this time we have a huge amount of candidates because it is an online event. So 30%, if it is 100, then 30 people can join. If it is more than 100, more than then you can have more internal people. तो 100 के जगह में अगर 200 participants हो गया तो internal हम लोग 60 भी accommodate कर सकते हैं. Okay, so no problem. So Smita, you got Jayanto sir's number. If you are interested, you can join in, and others also. I'll be sharing it in the Google Classroom. So that is the elementary workshop. So it is not that you need some prerequisites for them. Rather, the prerequisites will be given of quantum computing here. And in the next workshop, if you are interested, then only you join the next one. So, but this one is only elementary. Okay, clear up to this?
Yes, sir.
So I'm stopping here, and tomorrow we'll be joining in the same time. Or will you, today are you joining that program? That some program is there at 10 a.m. I don't know whether you have integrative one. Anyway, so tomorrow we'll be joining in.